Figure 6.5 Promotion Hierarchy for Fundamental Data Types. In C++, when you have expressions that use multiple different types of data from the fundamental data types, which are listed here in Figure 6.5, you're going to automatically get certain promotions as part of those calculations. Now, the promotion hierarchy that you see here lists the data types in descending order, basically. So a type lower in the list can be converted to any of the types higher in the list. So as you can see here, for example, all of the integral types can be converted to float, double, or long double, which are the floating point types. On the other hand, a floating point number cannot be converted automatically down to any of these other types because that would result in the loss of data in most cases. And in C++, it will typically give you a compilation error if you try to convert an argument or a value of one of these higher types to one of the lower types in the list. And this can come into play in a number of different scenarios. It can happen certainly in a mixed type arithmetic expression, in which case all of the values within the expression will be converted to the highest type in the expression. So for example, if I have an int and a double, the int will be promoted or coerced, if you will, into type double, then you'll have a double calculation. And similarly, if you have a long and a double, the long would be converted to a double, etc. By the way, notice that long int is synonymous with long, and you see some synonyms for several of the other integral types as well. Another case where you could get these promotions is when passing arguments to a function. So for example, if you have a function that expects to receive a double, it can technically receive a value of any of these lower types in the table. Similarly, a function that expects to receive an int can only receive int and lower types in the table. If you try to pass in a value of a higher type, you will get a compilation error in C++. In C, typically you'll just get a warning indicating that there might be a loss of data. So this is one of the differences with respect to data type conversions, or implicit data type conversions, I should say, in C++. You can always perform an explicit data type conversion in C++ using the static _cast operator, which we discussed in an earlier lesson.